Okay, this is Unit Test 3, and these are questions 6 through 10 that we're going to do here for you. Um, and questions 6 through 10, if you look at the data for how people did on this question, um, question 6, we had less than a 60% success ratio. And we asked that people try to do this by the complete the square method right here. So we're not sure if it's the complete the square method. We kind of think it is. People are trying to complete the square method, and they're just not being successful with it. So they need to see that a little bit more. And then equally, well, not really as difficult. Question 7 about the irrational expression, uh, 2x plus 1. Here, less than a 50% success rate. There, primarily the problem appears to be that students are not rejecting one of the extraneous answers they're getting. So we're going to emphasize that. Came back up a little bit with the complex compound fraction question here. Um, and so we'll talk about that. Talk about how you can do that question. Maybe make those a little bit easier for people. Question 9, we got to go back and talk about structure a little bit because this question is not that difficult. Um, and then the other real problem that came up there is people wanted to give us the imaginary answers as well. And so that is a little bit on us, we feel like. We maybe should have said solve for all values of x over the reals. Um, Something of that nature in the general instructions for the program because you'll be doing the calculus of the real variable. And so we don't allow the imaginary or the complex in the Calc 1. So that's what's going on there. And then in number 10, a little issue with factoring. And that too goes back to structure, I think. So we're going to look at those questions in this video, see if we can't help you out a little bit with them. I'm going to start with number 8 right here. And the reason I'm going to start with 8 is I want to clear out that space to kind of give you again the bullet points when we do this complete the square question for number 6. So if you look at number 8, complex fraction, you have denominators of k and k. So one technique is to multiply major numerator and major denominator by all the denominators you see in the question. And in this case, that is going to be just a k. So if there were other denominators, we'd multiply by those too. But the only denominator in the question is a k. Now, in the numerator, when you multiply 2 over k times k, that's going to give you just a 2, right? So we're multiplying by a form of 1. We're not changing the value of the whole fraction. And in the denominator, when you multiply by k, you're going to have to distribute. So you're going to have 1 times k is going to be k. And 2 over k times k, just like in the numerator, that's going to be a plus 2. So there's your answer, right? And easiest way to do that, when you click in the answer space on WebAssign, you'll get a thing called a MathPad or a CalcPad, and it helps you to enter symbols and uh, syntaxes and things of that nature that might be a problem. And in this one, because my answer is a fraction, I would click on the little symbol that looks like a fraction. That will give me that kind of arrangement, and then in my answer space, I can put the 2 in the numerator, and then you just move your mouse to the denominator and you click in there, and then you can type in the k, and you want to be sure you use a k and not an x plus 2. We did have that happen for a very few students. The variable is k, so the solution is looking for k. And if you use an x, it's going to mark it wrong. All right, so be aware of that. Now, from here, we're going to clean up this space. So let us know if you need more help with complex fractions, if you're still not getting that idea. And now I want to talk about the complete the square method. Okay? So make a few notes here about complete the square because a lot of people are experiencing a little frustration with this. So complete the square. Step one, force A to be 1. All right. Now, right now, A is a 3. So I'm going to divide everybody by that A value. That's the way you do that. You divide by A. That's how you accomplish that, forcing A to be 1, right? So I divide all terms by the A value. And that's going to give me x squared minus 3x minus 2 equals 0. Then in the video we put up earlier, our next step is to remove c to the 0 side. Okay? Remove c to the 0 side. So c is right here. C refers to the constant value, just like a referred to the coefficient of the square term. B is the coefficient of the x term. So I'm going to remove c to the 0 side, and I'm going to leave a hole right there when I do that. This space I'm going to leave right there. Okay, so how you do that? You leave a hole. Okay, trying to keep these directions simple. So I'll say leave a hole. And that means where the minus 2 was, where the constant was, you leave a space right there. Okay, then the next thing to do is factor by splitting b. Okay, uh, divide by 2 is how you split b. And to factor, we're talking about the reverse FOIL technique that's so familiar from high school. So obviously, by forcing a to be 1, we set ourselves up so that this is going to be easy to factor. It's going to be an x and an x. So the two things are going to be the same. Remember, we're trying to get it to be a square. So we're trying to get it to be something times itself. Okay? Now, the split b refers to taking this negative 3 and in the factored form, writing this as 3 over 2 and minus 3 over 2. So whatever that sign is goes with that. 3 over 1 becomes 3 over 2 in each of the two factors. And again, you get the idea, hopefully. Now, you're writing the same thing. So that's the idea behind the square. Okay? And then don't forget the square back. Now, the square back, what that refers to is the filling in of this hole, right? This hole that we made right here. When you FOIL factor, you end up with the first term, right? The outside pair and the inside pair. You also, after you split this b, you're going to square back because you have to do last term times last term. And it's going to be plus 9/4. All right? And I'm going to say, let me use my eraser for just a second right here because I want to make a little space right here for a comment. I'm going to say both sides because look, I just added 9/4 over here on the right hand side of this equal sign. Okay, so that's going to throw it out of balance, right? I gave the right hand side something it did not have. So you've got to add that same thing over here. All right. Now, here's where we think the error occurred. Here's where we believe the error occurred. We write it as a square, right? We write it as a square. And in writing it as a square, what, what happens from there is we're going to be able to use our square root form to get rid of that square, right? But on the right, we think all kinds of people made an error right here because we ended up with all kinds of people who had 11 under their square root. Well, look, in order to add these two values over here, this 2 plus this 9 over 4, you've got to have a common denominator. And that's going to be 8 over 4. All right? So, right, multiply top and bottom by 4 to get the common denominator. So that's going to be 8 over 4 Didn't make a very good 8 there. And of course, this is 9 over 4. So that's 17 over 4. All right. And that is where we think the error occurred on almost everybody who missed it, who gave us a response, right? And again, on this one, the success rate wasn't real good. So from there, I'll just use this space over here. I've got x minus 3 halves squared equals 17 over 4. Well, do a square root. That will get rid of the squared side, right? And of course, you got to do that square root over on the right hand side. So we get x minus 3 halves equals plus or minus, because we did a square root, right? 17 over 2. Okay? Now from there, to get the x alone, we bring the minus 3 halves over, and typically you put that in front. So that's 3 halves plus or minus square root 17 halves. Now, two things. First of all, that's two answers right there. There is no way in WebAssign to put a plus minus sign in like that. You can't do that. So if you're going to write this in the WebAssign box, you're going to have two answers, because there are two answers, separated by a comma. You're going to have 3 halves minus square root 17 over 2, and you're going to have 3 halves plus square root 17 over 2. And that's it. No x equals, no parentheses around it. You just put in multiple answers by separating them by commas. Now, of course, the other thing is you already have a common denominator there. So it would also be entirely possible to use your WebAssign and put your answer in like this. 3 minus rad 17 over 2, comma, 3 plus rad 17 over 2. And typically people do that by on the calc pad using the fraction uh, object. And then they just enter their numerator, then they click in here and enter their denominator. And it makes it easy as can be. A little bit of practice and you should be fine with it. So after you write it as a square, you solve by square root, and then from there it should be fine. I'm going to clean this up. I'm going to get rid of this stuff right here to make ourselves some space. And so that is now gone, and hopefully complete the square is a little bit easier for you. If you need more help with complete the square, there are videos on the YouTube site for complete the square. And if you need another one made, do not hesitate to contact us. Our goal is to help you. Um, from here, I'll look at number 7. I kind of did it up for you right here. Um, Move the x from the left-hand member to the right-hand member by subtracting it. Use the additive inverse. That isolates the radical. You square both sides, right? So you do a square here, and you do a square here to get rid of the square root. Okay. 7 minus x squared, you should get 49 minus 14x plus x squared. Then from there, you see the x squared right here, so that makes you think get one side to 0. So I've got x squared. Now notice minus 16x, because the 2x came over and you subtract it, and plus 48. That 49 right there, you subtract the 1, becomes 48. All right. And then in terms of factoring this, we get 4 and we get 12. Okay. And from that factorization, x minus 4 equals 0, we get x equals 4. And x minus 12 equals 0, we get x equals 12. And then people went to WebAssign, right? And they entered 4, comma, 12. And they got the big red X. They got the big red X because this 12 is a liar. That 12 does not work, right? And again, this comes back. I know we're harping at it, but it comes back to seeing structure. right? Think about this. This is a positive number, right? That's got to be a positive number. There's no way that can be negative. Plus, suppose you think the answer is 12, and you're going to get 7. You're going to add 12 to a positive number and get 7. You sort of structure-wise can see that that answer need to be rejected. So the only answer to question number 7 was x equals 4. Okay, the 12 was what we call an extraneous answer. It's an answer caused by the technique of solution. All right. So with radicals, you need to be careful and check your answers on those. All right. So that's question number 7. Question 9. All right. This is as I mentioned, this a little bit on us because well, a lot of people we think saw what was happening, but we didn't mention that we're only looking for real answers. And so we'll probably change that question for the next iteration of this program. The factoring is pretty easy. X squared minus 9, x squared plus 4, right? It looks just like this kind of thing from elementary algebra in high school, which, should be easily factored by maybe reverse FOIL, or maybe you factor it by split the middle, or whatever technique you learned to factor with in high school. This is the same thing. See, this exponent is the double of this exponent. So it's just going to factor in that same form. And then the x squared minus 9 is a perfect situation. So you're going to factor that into x plus 3 times x minus 3. And then the x squared plus 4 doesn't factor over the integers. Doesn't factor over the integers. We'll talk more about that in just a second. So x plus 3 equals 0, x minus 3 equals 0. That gives us two answers, minus 3 and 3. The x squared plus 4, what we think a lot of people did was this. And then they said, okay, got to do a square root to get rid of the square. So x is plus or minus square root negative 4. And of course, seeing that, they went to plus or minus I, right? Square root of 4. And of course, square root of 4 is 2. So we had a number of people come up with plus or minus 2i as another answer. Okay. The thing is, we were only looking for real answers. And that's why if you entered this as plus or minus 2i along with the minus 3 and 3, why it got marked wrong. So that's a little bit on us, and we will change that wording for the next iteration. Okay. So all we should have been seeing was 3 and minus 3 and so on. So sorry if that bothered anybody with that question. Um, and then question number 10, right up there in the upper right hand side of the screen. This is sort of a structure issue, right? Our argument is going to be if you knew how to do this in high school, if you knew how to factor that in high school, this is the exact same structure. 2x to the 2/3, 3x to the 1/3. That's exactly the same 2 to 1 relationship between those exponents. And so in terms of factoring this thing, it's going to be a 2x to the 1/3 power and an x to the 1/3 power. And that's where you're going to get your 2x to the 2/3. Because when you multiply, just like in elementary algebra, you add the exponents. So that's going to give you your 2x to the 2/3. Okay. Signs are different. And the good news is right here, the constant, right? The only multiples of 2 are 1 and 2 over the integers. And since I want a 3 in the middle, I would put the 2 down here. That way, when I do my outer pair, I'll get a 4. And then put the 1 in here. So since we want a plus 3, I'll put the plus 2 there. And I'll put the minus 1 here. Signs, again, are different, right? Or you could use AC method that we've talked about on this. 2 times 2 and split the middle and just let the x to the 1/3 exponent take care of itself. All right? So that factoring seems to be a bit of an issue for people. So now we've got x to the 1/3 power plus 2 equals 0. So that gives us x to the 1/3 power equals -2. I had a few questions on this. Easiest way to think of this, that 1/3 power, when you have a fractional exponent, right? A over B. The B is the root, okay? The A is the power when you have a fractional exponent. So this means the B root of x to the A power. Or if you prefer, you can write it as B root of x to the A power. You can do it whichever way you want. So this means cube root of x is -2, right? So now if in elementary algebra you know how to solve this, right? If you know how to solve the square root of x equals 4, right? You square both sides. So x would be 16. In here, you have a cube root, so you raise it to the 3rd power, right? Think of it with the fractional exponent, if you like. When you raise a power to a power, what do you do with the exponents? You multiply the exponents. So that's going to give you just plain x to the 1st. Equals, now it's -2 that you're cubing, and you're going to get -8 out of that, okay? And then from there we go to the other side, and we have 2x to the 1/3 minus 1 equals 0, okay? So 2x to the 1/3 equals 1. So x to the 1/3 equals 1/2 divided by 2. And then you got the same situation that you just had over here on the right. You have a cube root. So to get rid of the cube root, you're going to raise it to the 3rd power. So what's 1/2 times 1/2 times 1/2? Well, it's 1/8. So your WebAssign answer, 1/8 and -8. All right. So that's questions 5 through 10. We hope you found them helpful. And so keep working at the stuff a little bit every day. It'll make the difference for you come fall.